Welcome to SAT School. This is our 7th video on probability and second video on tree diagram. Let's get started. Now here is practice question 13. From a well shuffled pack of 52 playing cards, 2 cards are drawn without replacement. Now we have to show the probability that both cards are king in a tree diagram. Here we know we have 52 cards, of them 4 are king. Let king be k and not king be k bar. We have to show probability that both cards are king. So let king is k and not king is k bar. We have 4 king and 48 not king. So out of 52, 4 king and 48 not king. In the first draw, now we have to find probability using tree diagram. We simply make branch like this. So this is the branch for probability of king in the first draw, and this is the branch for probability of not king in the first draw. Again, this is for probability of king in the first draw, and this is probability of not king in the first draw. As we have 4 king, the probability of king will be 4 by 52, which is 1 by 13. There are 4 king out of 52. Now to find probability of not king, that should be 48 by 52, which is again 12 by 13. So this is the probability of not king, which is 48 out of 52. So this is 48 which are not king and simply 12 by 13. Now after first draw, by the question, a card is not replaced. So this is without replacement, meaning in every draw or when a card is drawn, then you have to reduce one card in every draw. So when you go to second draw, now there will be 4 king. Out of 4 king, there will be 3 king left as we go to second draw. So again, this is for probability of king in the second draw, and this is for probability of not king in the second draw. Same is for here. So this is what we saw in tree diagram. First 2 branches, again 2 more branches from here and 2 more branches from here. Now here we have cards which are 3 king and 48 not king. The reason is, what we assume here is a card is drawn which is king. If a king is drawn here, then by the question without replacement mean we don't replace the king which is drawn. That's why there are 3 king. Now 48 remains same, because what we assume here, a king is drawn in the first draw. Now when we come here, we assume here a card is drawn which is not king. That's why there are 47 not king. This 4k remains same. The reason is we assume a card is drawn in the first draw which is not king. That's why we have to now reduce 48 into 47, and this one remains same. This is just opposite. Here a card is drawn which is king, that's why this is 3k. Here a card is drawn which is not king, that's why this is 47. Now again, this is same. This is the probability for not, this probability for king in the second draw. Here we have 3 king. Now that should be equal to 3 by 51. We have 51 cards, so this is 51, and we have 3 king. Now this is for probability of not king, that is 48 by 51. We have 48 which are not king, and all we have 51. This branch is for probability of king, which is 4, in this case 4 by 51, and this is for probability of not king. We have 47 which are not king, so this would be 47 by 51. Simply, this is how we draw tree diagram. Now we have to find the sample space. So these are sample space, meaning this branch is for probability of king in the first row and probability of king in the second row. So this is probability of king in the first row, probability of king in the second row, which is equals to multiple of 1 by 13 and 3 by 51. So that is equals to 1 by 13 times 3 by 51. Now if you cancel this one, and if you simplify, that is equals to 1 by 2 to 1. As we have this sample space, now for this is the probability of king in the first row and probability of not king in the second row. So like this. And this one for probability of not king in the first row, probability of king in the second row. And this is for probability of not king in the first row, probability of not king in the second row. Simply, now this is the product of this one and this one, and this is the product of this one and this one, and finally this one and this one. So if you simplify, then you can find the values. Now the question is to find the probability that both cards are king, meaning this one. So this is for probability where both cards are king, which is 1 by 2 to 1. This is probability of getting two cards which are king, 1, 2 to 1. So this is how we saw in tree diagram. Now here is practice question 14. Two cards are drawn randomly from a well shuffled pack of 52 cards in succession. This is also without replacement. Now we have to show the probabilities of possible outcomes of getting jack and not getting jack in a tree diagram. This is what we did in practice question 13. Instead of jack, there was king. Now you have to find the probability of getting jack and not getting jack. The process is exactly same. We have 52 cards. Out of 52, we have 4 jacks and 48 not jack. So you can say let jack equals to j and not jack equals to j bar, and follow the same process, exactly same. The difference is the question is asking getting jack and not getting jack. So only this is the difference, and the process is exactly same. I think you can manage this. Complete this challenge. I'll meet you in next video. Take care, and don't forget to subscribe. Press the bell icon so that you can get the notification as soon as I upload my video. Take care.